Hi, good day. This is once again Teacher Rica, your math teacher. Today we will talk about addition of polynomials. So let's recall what are polynomials. A polynomial is an algebraic expression involving only addition and multiplication of numbers and variables. When a term in the expression has a variable in the denominator, or when the exponent is a fraction, the expression is not considered a polynomial. Example of a polynomial is the algebraic expression y cubed over 2 minus 8y squared plus 6y minus 1. So in here, we cannot see any fractional exponent or a variable in the denominator. Non-polynomials are 5 over m squared, 5m raised to negative 2, 3v raised to 2/3, and 3 times the cube root of v squared. So why are these non-polynomials? Because of the variable in the denominator, which is m squared. So 5m raised to negative 2 is the same with 5 over m squared. And because of its fractional exponent for 3v raised to 2/3, which is the same with 3 times the cube root of v squared. Terms in the polynomial can be added if they are similar. Similar terms contain the same literal coefficients, so same variable and exponent. So similar terms are the only ones that can be added. For example, 3m squared and negative 5m squared, we can combine the two by addition. X squared y z to the fourth all over 9 and negative x squared y z to the fourth. So why are they similar terms? Because aside from that they have the same variable, they also have the same exponents. They have the same variable xyz. So in here xyz. And same exponents, 2 for x, 1 for y, z, 4 for z, as well as in here. 2 for x, 1 for y, and 4 for z. Examples of the similar terms are negative n to the fifth and 10m to the fifth because they have different variables. And x to the fifth, y to the fourth, z to the third, and 8x to the fifth, y to the fourth, z squared, because even if they have the same variable x, y, z, they do not have the same exponents. So they differ with the exponent on z. How to add polynomials. Let's say you're given 10y squared plus 6y. So that's very simple. You simply add the numerical coefficients, 10 plus 6, which is 16, and then copy the literal coefficient, y squared. Negative 5m cubed n plus 13m cubed n. So what you have to do is to add the numerical coefficients, negative 5 plus 13, which is equal to 8. And then copy the literal coefficient, m cubed n. How about 7x cubed plus x squared minus 11x plus 1 plus the polynomial 5x cubed plus 9x squared plus 6? So what we have to do is to arrange terms in the same column. Arrange similar terms in the same column. So 7x cubed and 5x cubed are in the same column because they are similar. X squared and 9x squared are in the same column because they are similar. Negative 11x has no pair. And then the constants 1 and 6. So from there, you can add them one by one. 7 plus 5 in here, that is 12. Then copy the literal coefficient x cubed. So in here, there's an invisible numerical coefficient of 1. 1 plus 9, that's 10. Copy the literal coefficient x squared. Negative 11 plus 0, so that's negative 11x. 1 plus 6, that's 7. So the answer to that is 12x cubed plus 10x squared minus 11x plus 7. So let's have some practice. How do we add the polynomial 6x squared plus 5x cubed plus 2x and x squared minus 1? So what we have to do is, you can arrange the terms here from the highest exponent, from the variable with the highest exponent up to the least exponent. So what we have to do is to start with 3, followed by the variable having 2 as an exponent, and then lastly, the variable with an exponent of 1. So when we rearrange it, we started with 5x cubed, and then 6x squared, and then 2x. And then after that, we put in the same column those terms that are similar. So there's no pair for 5x cubed, 6x squared, and x squared. We put them in the same column. There's no pair for 2x, and then write -1 here, which has no pair as a constant. So add, since 5x cubed has no pair, bring it down, and then 6x squared plus x squared, so that's 6 plus 1, there's an invisible 1 there, 6 plus 1, that's 7, and then copy the literal coefficient, this one, and then 2x, that's bring down, 0 minus 1, or 0 plus -1, that's -1. So the final answer is 5x cubed plus 7x squared plus 2x minus 1. How about if we're given -10y squared plus 9y to the 4th plus 12y cubed plus 36y minus 7, and add it to the polynomial 9y cubed plus 8y squared minus y plus 1 plus 12y to the 4th. So to avoid confusion with similar terms, we can rearrange the terms in the polynomial from the variable with the highest exponent to the least, or to the variable with the least exponent. So for the first polynomial here, the one with the highest exponent is this term. So we will start with that term, 9y to the 4th, followed by 12y cubed, -10y squared, 36y minus 7. So arranging them with a variable from the highest to the lowest. So the exponent here is 1, and there's no variable in here. So arranging the terms from the variable with the highest exponent to the least. So for the second polynomial, we will start with 12y to the 4th, followed by 9y cubed, and then 8y squared, and -y plus 1. So 4, 3, 2, 1, 0. And then add vertically. 9 plus 12, that's 21. Copy the literal coefficient. 12 plus 9, that's 21. Copy the literal coefficient, y cubed. -10 plus 8, that's -2. Copy the literal coefficient, y squared. 36 plus -1, so that's 35. Copy y. And then -7 plus 1, that's -6. So the sum is 21y to the 4th plus 21y cubed minus 2y squared plus 35y minus 6. Another item, 12z to the 5th minus 13z to the 6th plus 9z to the 4th plus z squared minus z plus 1. So what we have to do is to arrange terms that are similar on the same column. Now, since there are no terms that are similar, you simply add them all, copy. So there's no pair for -13z to the 6th and 12z to the 5th. So you simply bring them down, bring this down. So the sum is this whole expression here. And then lastly, 14a cubed plus a squared minus 11 plus -6a cubed minus 5a squared plus a minus 2. So we can rearrange the terms from the term having the highest exponent in the variable to the term with the least exponent on the variable. So when we arrange for the first polynomial, we start with 3, 2, there's no linear term here, and then lastly the constant. So for the second polynomial, we started with the variable having 3 as an exponent, then 2, then 1, and then the constant. So add them vertically, 14 plus -6, that is 8. And then copy the literal coefficient, a cubed. And then we have 1 here, which is invisible. 1 plus -5 is -4. Copy the literal coefficient, a squared. And then bring down 0 plus a, that's a. And then -11 plus -2, that's -13. So the sum is 8a cubed minus 4a squared plus a minus 13. So as you see, that's the sum. In addition of polynomials, arrange the terms from the term with the highest exponent going to the term with the least exponent, or the other way around. So we can also arrange them from least to highest in terms of the exponent. Arrange similar terms in the same column and add similar terms only. So we have here an activity in which you can answer. If you're interested to answer this, you can pause the video. Now that's it. That ends our discussion about addition of polynomials. I hope you learned from this lesson. And I hope you're also following the other videos that I made because they are interconnected. Don't forget to subscribe and click the notification bell to get notified for the next videos. Thank you and see you for the next lesson.